Welcome to the Chapter 6, Part 6 notes video. We did composite functions in class. We'll have more time to talk about that in our upcoming class as well. This video is adding, subtracting, multiplying, and dividing functions. So this is if I'm not composing the functions, if I don't have something like f composed with g of x, I could have f minus g of x, or g plus f of x, or f times g of x, or f of x over g of x. Now we can use other letters. It doesn't have to be f and g. It could be h plus k of x. It could be a times m of x. These are just names of the functions. So we saw already in class, you might have seen that sometimes we'll have an f of x, of g of x, and an h of x. And so it doesn't always have to be f composed with g or g composed with f. We can use different variables to represent the functions. Just like we saw in class, the key to doing operations with functions is substitution. Okay, we're also going to be looking at domain. So remember that domain is all of our possible input or x values. The domain is what values can I substitute into the function and still get a real number back. Okay, so here's some notation. If I see f plus g of x, that means f of x plus g of x. This is not the same as distributing. Really what we're looking at is that x could turn into a number. So I could have something like f plus g of 3. That tells me that my x value is 3. So then I would say this is f of 3 plus g of 3. Okay, same thing for subtraction, multiplication, and division. However, for division, we have a denominator, so that denominator cannot equal 0 because we can't divide by 0. When we're looking at these types of operations, our domain is the domain of both functions. So if there's a function that works in f of x but doesn't work in g of x, then it can't be in our domain because I have to be able to evaluate both f and g of x. So let's do a quick review of domain. It's been a while since we talked about domain. There's actually two types of limitations that we have on domain. We cannot divide by 0. So our denominator can't be 0. And we also can't take the square root of a negative number. Now we did learn that it's possible to take the square root of a negative number to get an imaginary number. But in this case, we're looking for a domain of real numbers. Okay. So let's look at dividing by 0 first. How do I know what values I can substitute for x? Well, x can be any number except for 0 because my denominator can't be 0. So this cannot equal 0, x can't be 0, meaning that if I looked on a number line, here's 0, x could be any number except for 0. So x is all real numbers except x is not equal to 0. Okay, if we wanted to write that as an interval, we could say from negative infinity to 0 and 0 to infinity. Everything except for 0. And remember, this is the union sign. Union goes between any intervals that we have that are connected, if there's a gap. Okay, in our second example here, again, I want any value except the denominator cannot equal 0. So if x minus 2 can't equal 0, then x cannot be 2. So x is any real number except x cannot be 2. So the domain is all real numbers except 2. If I write this as an interval, it would be from negative infinity to 2 and from 2 to infinity. Union again. Because I have two parts, I have to skip over the value of 2. Same thing, notice we're not looking at the numerator for any of these. 3x plus 9 cannot be 0, otherwise we would be dividing by 0. 3x cannot be negative 9. X cannot be negative 3. So now we have the domain is all real numbers except x cannot be negative 3, or as an interval, that would be from negative infinity to negative 3. Pick up on the other side of negative 3 all the way to infinity. Okay, so that's our denominator. That's the first case that we have to worry about. If my value, if my function is not a fraction, then I don't have to worry about it. If there is no denominator, and specifically if there's no variable in the denominator, we don't have to worry about it. The other case is if there's a radical. So we can't take the square root of a negative number, so we know that the radicand has to be greater than or equal to 0. So that means that 2x plus 8 has to be greater than or equal to 0, minus 8, 2x has to be greater than or equal to negative 8, divide by 2, x has to be greater than or equal to negative 4. That means x can be from negative 4 and anything bigger, and equal to, so I can put a square bracket. So my domain here would be from negative 4 to infinity, or I can say any value greater than or equal to negative 4. In our next example, the same thing. I have a square root, so the inside cannot be negative. X squared minus 9 has to be greater than or equal to 0. X squared has to be greater than or equal to 9. Okay, now this is a little bit tricky because we have an x squared greater than or equal to 9. Well, if we remember what values squared are greater than or equal to 9 on a number line, here 0, 1, 2, 3, negative 1, negative 2, negative 3, anything from 3 and bigger will definitely be bigger than 9, but also anything from negative 3 and smaller will be have a square that's greater than 9. Okay, so when we're looking at what values of x give us a greater than or equal to a 9 value, we are looking from negative infinity to 3 bracket, because that could equal 9, union, sorry, that should be a negative 3, 3 to infinity. Okay, and our last one, what about when our radicand is 4 minus x squared greater than or equal to 0? Then 4 has to be greater than or equal to x squared. So now my x squared has to be smaller than 4 on a number line here, 0, 1, 2, negative 1, negative 2. That means equal to, I can include 2 and negative 2. Does 0 work? Is 4 greater than or equal to 0 squared? 4 greater than 0? Yes. So we know it's in the middle. So then we can say my domain here is from negative 2 to 2 only. Okay. If you want to look at more examples and practice problems, we did this, I believe it was chapter 2 that we did more similar problems to these. Okay, so an example of how we're going to apply this to functions. I have f of x is 4x plus 7 and g of x is the square root of x plus x. We need to find the sum and difference of the functions. Okay, so f plus g, which means f plus g of x. If there's nothing given, then our variable stays as x. That's the same as f of x plus g of x. So these three are just different ways to write the same question. So we're going to substitute f of x first. That's 4x plus 7 plus g of x, which is the square root of x plus x. Can I combine any terms? We have 4x plus x plus 7 plus the square root of x. All I did is I moved my plus x over. So this is 5x plus 7 plus the square root of x. The order that you write these terms doesn't matter. So if you want to put the square root first, that's fine. If you want to put the square root second, that's fine. But they should all be positive. Okay, so there's my function. To find the domain, first we check and there's no denominator. Second, we check for radicals. I have a square root of x. That tells me that x has to be greater than 0. So my domain is from 0 to infinity. Sorry, this should be greater than or equal to, because I can take the square root of 0. So domain is from 0 to infinity. Let's try f minus g, which is f minus g of x, because there was no variable given. So this is f of x minus g of x. Those are just 3 ways to write the same thing. 4x plus 7 minus the square root of x minus x. Notice every time I'm substituting into parentheses so that I can make sure to follow order of operations. Distributing that negative, I have 4x plus 7 minus the square root of x minus x. 4x minus x is 3x plus 7 minus the square root of x. There's our function. For the domain, we need to check first, denominator, there's none. Second, radicals. I have a square root of x. That tells me that x has to be greater than or equal to 0. So my domain is again from 0 to infinity. Okay. So that's adding and subtracting functions. I want you to take a look at the difference here. When we're looking at adding and subtracting functions, we had a plus or minus between our f and g. Now we have a multiplication sign, which is not the same as a function composition sign, right? In class, remember I said it's an open circle. It's important that you write it as a circle and not a dot, because the dot will represent multiplication, okay? And then f over g is division. So let's look first at f times g, or f times g of x, which is f of x times g of x. So substituting f of x is x squared minus 9 times g of x is x plus 3. If I'm multiplying binomials, that means we are going to need to distribute or FOIL. So that's x cubed plus 3x squared minus 9x minus 27. I have no like terms, so that is my function. To find the domain, I want to check for denominators. There's none. Radicals, there's none. None of either means the domain is all real numbers, or from negative infinity to infinity if you wanted to write it in interval notation. For f over g, or f divided by g of x, that's f of x divided by g of x. So that means f of x in the numerator, x squared minus 9, g of x in the denominator, x plus 3. Okay, now this is important. I can actually simplify this fraction, right? So this is going to become, let's do it, x plus 3 times x minus 3 divided by x plus 3. It's factored. There's no addition or subtraction outside of parentheses, so I can simplify this to just x minus 3. However, I did have a fraction at one point. So when I look at my domain, when I'm looking at the denominator, I need to consider x plus 3 could not be 0. Otherwise, I wouldn't have been able to simplify. So this means that x cannot be negative 3. I also want to consider radicals, but there are none. So that means my domain is all real numbers except x cannot be negative 3. So that's from negative infinity to negative 3, and also from negative 3 to infinity. Whoops, I forgot my last parentheses. There we go. Okay, so when you're doing division, there's kind of that extra step of you're not just looking at the final answer. If you simplified the fraction, the denominator that you had earlier is still considered for the domain. Okay, so we've seen an example of each. I want you to try these ones and then we'll look at the answers together. Okay, so start piece by piece. The first one, f plus g, if I add the two functions together, you should get 2x squared plus x plus 5 with no denominators and no radicals throughout the computation, so that the domain is all real numbers. If we subtract the two functions, you get 2x squared minus x plus 11. No denominators and no radicals throughout the computation, so our domain, again, is all real numbers. And then if we multiply our two new functions, you have to distribute. So you should get 9x cubed minus 30x squared minus 23x minus 4. Again, there's no denominators or radicals throughout the entire computation, so our domain is all real numbers. And then lastly, f divided by g. I can factor the numerator, and I have the work for factoring here on the side if you wanted to reference that. So I can simplify my function to just x minus 4. However, even though there's no denominator in the final answer, there was a denominator that I used to reduce, and so I have to set that denominator not equal to 0. So x cannot be negative 1/3. There are no radicals to work on. So our domain here is that x cannot be negative 1/3. If you wanted to write this in interval notation, that would be negative infinity to negative 1/3 union negative 1/3 to infinity. Okay. So your homework to turn in for the Edpuzzle video is these 6 problems. Notice some of them are multiplication, some of them are composition, adding and subtracting. So you'll get a little bit of variety with the same 2 functions that are given at the top. Okay, if you have questions, feel free to email me. Otherwise, I will see you in class.